What's going on, everybody? Thanks for tuning back in. Today's a great day because, as most of you know, learning how to make a state machine isn't something you can just Google and find a tutorial on and understand everything. So today, what I'm going to do is I'm going to show you how I create an AI state machine in Unity, and hopefully you understand how I do this, and you can eventually use it for your own game and modify it any way that you like. So I'm going to make a new project here called AI State Machine Example. And I'm going to create that project. I'm just going to let it load. The reason I'm making this video today is because when I first started programming with Unity and I started making video games, I looked for all sorts of ways to make a state machine. People did it with one class. People did it with multiple classes. People had all sorts of ways of attacking it. So I'm going to show you the way that I learned how to do, I modify for myself, and I think this is the best way to attack it. So what we're going to do right now is we're going to make a couple scripts, and the first one we're going to call it state machine. This is going to be the beef right here. And we're going to make two states. I'm just going to show you the state machine basic with two states just so you can see how they switch back and forth. So we're just going to call this one first state. And then we're going to call the second one second state. Also, for the example, we're just going to make a little script here. We're going to call it AI. This script is the example script that you would be using, that the state machine would be attached to. This would be what is on your game objects that are controlling your AI. For example, if you had your AI going through different movements, or a patrol state, an alert state, an attack state, a fleeing state, all those things would be controlled from the state machine, but it would need to link this AI file right here. So the very first thing we're going to do is we're going to open this state machine file, and we're going to get to work in creating the backbone of the state machine. So the first two things we're going to make aren't mono behaviors. So if you're ever making something in Unity that's not a mono behavior, you have two ways you can do it. You can make something a system.serializable, and that'll make it viewable in Unity if you're not using any namespaces that the engine already recognizes, or you can make a namespace. Personally, I like to go with the namespace option, and that's only because I've been using C# for as long as I have. If you prefer using system serializable, you can go right ahead, and that'll maybe make your job a little bit easier, but I'm just going to make a namespace, and I'm going to call it state stuff, because we want to be super technical and have the name stuff at the end. Okay, so let's get rid of everything up to this little point right here. So in our state machine, we're going to reference the states, the owner of the states, and we're going to be able to change the state and update the state. So before I can make the actual state machine, I also have to make a public abstract class state. And the reason I'm making this abstract is because this is what all our state files are going to be based on. Now, it's important to note that if I didn't declare that it was the AI file using the states wouldn't have anything to reference. So what you can do is you can do one of two things, and I'll show you the method I prefer. You can use these little brackets right here, and you could declare AI as your state machine's prevalent type, or you can make it ambiguous and declare it as type T, which means that not only the AI file that we made could use the state machine, it could be anything other than AI can use the state machine as well. And that could be useful if you have things switching between states. So let's just use T, just so we can keep it ambiguous. The very first thing we're going to do is we're going to want to declare a public state of type T, and we're going to call this our current state. Now, since I'm just making a basic state machine for you, I'm not going to declare any previous states or future states or anything like that. Whenever you're programming this in your own game, you can build off this, and it'll be more complex, but we're just going to keep this simple just so you can see how this works. We're also going to declare a public of type T, the owner, and this is the actual object that will be using the state machine. So now we have to make the constructor, and we're going to call it a state machine. And T we're going to pass in, just call it _O for owner. And we're going to make our owner equal to _O. Very simple. So when you do declare the state machine, basically in the AI file, we would declare it a parameter just saying this. and that would reference the AI and turn T into AI. And also, we don't want any current states. We don't want it to have any state right off the bat. We want to be able to declare that on our own. The next thing that we're going to do is we're going to have a public void. We're going to call this change state. This is how the state machine will go through your states. And we want to pass in a state of type T, and we're going to call this our new state. And the other thing we're going to want to do is we're going to want to be able for our states to update along with the updates on our mono behaviors, or if you're making a multiplayer game, your network behaviors. So let's make an update function. Okay, before I can fill out the change state and the update, I also have to construct the basic outline of what our states are going to look like. So they're going to have 3 functions that I find most prevalent. Doesn't matter what I'm designing, I always need these. We're going to have our enter state. Let's call this T object. That's going to be the object that owns it, or you could call it owner if you want to just stay with the. Yeah, let's just call it owner because that's what we've been calling it. And then public abstract void. Whoops. We're going to say exit state. We're also going to have a type T as our owner. And the very last thing we're going to do is we are going to have our update state. And we're going to put T owner parameter. So what this is going to do is, depending on the state that you're in, when you enter the state, you can have some sort of command going off depending what state you're entering. For example, if you are making a game where you have a combat state and you need shields to turn on or armor to turn on, right when you enter the state, if you only want something done once when you switch a state, this would be the perfect place for it. Or if you were changing from your alive to a death state, in your exit state, you would, kill off the object, something like that. So the next thing we're going to do is we're going to go back to change state here. And what this is going to do is it's going to exit the state we're currently in, switch the state, and then call the enter function of the new state. So let's call our current state. We can call our exit state. And we can just say it's the owner. Our current state, we're going to equal our new state that we're passing in, and then our current state, enter state. Very simple. Now, if you haven't noticed the way I've declared this, the first state that we're going to have is null. So if we change the state when we declare an AI class, this is going to mess up because there's no state to exit beforehand. So we have to do a little check here that if the current state is not equal to null, then we can call upon our exit state. But if it is equal to null, it's going to skip that, change into the new state, and then we'll never have to worry about that again. Same thing when we're updating. I'm just going to copy this right here. Every frame that we update, if we don't want to update the state if it's null, that's just going to throw a bunch of errors for us. So we're going to check if it's null or not, and then we are going to update the state. So let me just take a quick look here. I feel like that's all we need for this state right here. We're not even using any of these usings up here. I could probably get rid of them. But I just want you guys to see how this is laid out. So the order of when this is declared is the state machine sees who the owner is. And next, when you tell this state machine to change the state, it'll check if it's null. If it is null, it won't exit the state. But if it's not, everything is going to go smoothly. So our state machine is pretty much done. Now, the next thing that we have to do is we have to make our states. So if you're using Visual Studio like I am, everything should show up here. Let's go to our first state. Now, I can't just switch mono behavior and declare a state here because this file won't know where I'm getting the state machine nonsense from. So at the top here, I'm going to use my state stuff namespace that I declared before, and that is how you use a namespace if you've never done it before. So now let's change this first state to an actual state. And since AI is the class that is going to be using this particular state, we can declare AI here. As I said before, the reason why you want to declare it as a type T and not specific as is because anything right now can technically own this state machine. It's just the states that are specific. So the first thing you should notice is that you're going to get a little thing here saying that, hey, you're missing all these functions. So in Visual Studio, you can just click that and it will throw in all these wonderful new functions for you. I'm just going to delete these because you don't really need it. And so if it's not apparent to you already, what you see here is that your enter, exit, and update states all reference the object that owns it. So anything that is in my AI class that's public or has a public get function, I can access here. And this is going to be very useful. Now, the second reason that I find this state machine so appealing is because I don't use states that are declared for every single AI class. We use a static instance of one state, and that really saves overhead. So it's very efficient for the CPU and for memory if you have a bunch of different classes of this AI class sharing one state. So let me construct the state for you, and I'll show you what I mean. So the very first thing I'm going to declare is a private static pardon my spelling here, first state, and we're going to call this underscore instance. So what this is this static variable is only going to be declared one time. So I'm going to make a constructor too, but I'm also going to make the constructor private. And that is so that this state can only be created from within the state class itself. And you'll see how this is useful in a second. So when I'm in my constructor, I basically want anybody referencing this state to be referencing this instance of it. So if our instance is not equal to null, if our state already exists that we're going to be accessing, then simply all we want to do here is return. We don't want to do anything. Oh, I call this alert state. Sorry, I was thinking of a different game I was making. Now, if that was the case, that's taken care of. If not, what we're going to do is we're going to take our instance and make it equal to this. So the first and only time this gets constructed, we set this instance equal to just one instance of the state. Very simple. Now, in order to access this, we're going to have a public static get function. So we're going to make a public static. We're going to call it first state. And we're going to call this instance without the underscore in front, just a capital instance so you know which one you're referencing. And we're going to use C# get. So how we're going to get this is, first thing we're going to do, we're going to check if our instance is equal to null. So if this variable up here is equal to null, we are going to call our private constructor, and we're simply going to call it a new first state. And what that will do is if the state doesn't already exist, which it won't on the first time you access it, it will call this and then it will exist. So once we check for its existence, we simply return the private instance. And that's it. That's all you have to do to make a static instance of a state instead of making it so you have to declare it every time. So the next thing we can do, since we're using Unity stuff up here, when we enter this state, let's just make a debug.log saying entering first state. And I'm going to copy this. And what I'm going to say down here is, oh, that's the update state. I apologize. Right here, we're going to say exiting first state. Very simple. And we'll put the things we want to do an update after. So now that the state is pretty much good to go, we're going to go over to our AI class. And what I'm going to do is, I'm not going to go through and program an entire AI that moves around and, you know, is alert, not alert. Let's just make a real simple timer where, let's say, every 5 seconds we switch between states. That way you could just see how the state is activated through a class. So I'm going to just use a bool to do this. So let's just call it bool. I'm going to call it switch state. We'll set it equal to false. Yeah, just leave it false, I guess. We're going to make a public float game timer and a public int seconds equal to 0. The reason I am doing this is because I'm going to set it every 5 seconds, reset the timer, reset the seconds, and switch state. So one more thing that I want to do is I want to, can't forget the namespace we're using up here, state stuff. So I want to make a public state machine. Pardon me. And I want it to be using AI because that is the class we're going to be calling it from. And let's just call it state machine. And we're just going to get set here. The reason I'm doing this and not making it equal to anything is because you can't use the reference this outside of a function, I'm pretty sure. So if I use private void start. So what I can do here is I can take our state machine and I can make it equal to a new state machine of AI. And I can reference this out here. If I did this up here, it would throw me an error. The next thing that we can do is we can do our, when we start, we want the state machine to change state. And this is the magic command right here. So we want our first state dot instance. So we don't declare a new first state. We just simply use the instance that already exists. That's the beauty of using one instantiation instead of many. The next thing we're going to do is we're going to make our game timer equal to time.time. Okay, we're almost there, guys. Just hang in. So the next thing we're going to do is I'm going to make my update function. And so how I do a game timer is very simple. With time.time is greater than game timer plus 1. Reset the game timer to equal time.time. And we'll do seconds plus plus. And one more thing I'm going to do here is I'm just going to log how many seconds go by. So I'm just going to debug the seconds here. The next thing I'm going to do is if seconds is equal to 5, this is when I want my state to switch. So what I'm going to do is I'm going to reset my seconds equal to 0. And I'm going to make my switch state bool equal to the opposite of whatever it is equal to right now. And instead of making a if-else statement, you can just simply use the exclamation mark. It's very handy. There's one more thing that you have to do, and that is if you want the state machine to update the states, you have to call the state, the way we programmed it is we have to call state machine and we have to call update. That way, this AI class will hit this update, and whatever current state you are in, it will hit the update of that state. So for example, our first state. So what we can do inside our state now is we can check the seconds, or sorry, check the bool. So since it's originally equal to false, what we're going to do is we're going to say if the owner switch state is equal to true. If we just leave it alone, this means the same thing. Then we can do owner. Before I touch anything else here, I'm going to do, actually, no, I'm just going to type this in, and then we're going to go make that second state because I didn't make the second state yet. State machine dot change state. This is going to be second machine dot instance, so I'm just going to use first state dot instance because it's the only one I have declared. I'm going to come back and change that in a second. This is going to be the template for the other state too. It's going to look exactly the same. So let's get rid of the stuff we don't need here. Let's save. We're going to select all. We're going to copy that, and we're going to go to our second state. Select all, copy, or sorry, paste. And instead of first state, we're going to use second state. So I'm going to double click this. And this. So our second state looks remarkably similar to our first state. The only difference is that we want it to switch when the bool is false. So this is actually fine. So now we'll go back to our first state, change this to our second state dot instance, and that's it. So when the bool switches to true, switch over to the second state. When the second state detects that your AI's bool is false, it will switch back to the first state. So that should work no problem. Okay, so let's go get an empty game object and test this. You might get some errors saying that they're inconsistent line endings. I get this all the time. Just ignore this. Anytime you reload the project, it'll fix it for you. So let's make an empty game object. And we're going to drag our AI onto it. And we're going to hit play. So let's see what happens. So it says entering first state. It should count to 5 seconds, then switch states. And look at that. I'm going to pause the game for a second. So it entered the first state, counter the 5. When it hits 5, the bool switches the state detects that it switched. It exits the first state, entering first state. Sorry, I forgot to switch the text over, so I can do that right now. Just so you can see that I'm not making this up. It actually works. So second and second. Sorry about that. It's been a long day. Haven't had my coffee yet. So let's try that one more time. So entering first state, 1, 2, 3, 4, and then 5. Exiting first state, entering second state. Now let's see if it goes back. It goes back just fine, and we'll let it go one more time. And there you go. Looks like it works just fine. So like I said before, if you're using this for your AI, enter state is going to be a great place if you want things to happen one time when the state turns on. Same thing with exit state. If something needs to happen before you switch states, you put it here. Otherwise, if whatever your conditions you're checking or anything else you need, you just put into update state. And as long as you program it the same way I have, it will update every single time your update is called from your AI class. So there you have it, guys. There is a simple state machine that uses one instance of each state instead of multiple, which saves overhead and makes your game a lot more efficient. And this is especially useful in multiplayer, so you don't slow down the system. Okay, guys, thanks for tuning back in. I hope you enjoyed the video, and we'll see you next time.